solve the following differential equation. So here we got dr over d theta. That means r is dependent variable, theta is independent variable. Okay, dr over d theta, r times secant theta. So r is the variable. So solving here means we are trying to determine r, function r, in terms of theta, because theta on the bottom means that's the independent variable, equals cosine theta, and theta is given in between 0 and pi over 2. So we got r, that's the dependent variable, and its derivative, function r and its derivative, that means, and it's only here r, we don't have r in other places, so this is not a separable. We cannot separate the variables. Okay, this one is in the following form. So when we have some dependent variable, let's say y, and some function of x, plus its derivative dy over dx, okay, equals some function of independent variable. Okay, that's called linear differential equation. Y, function of independent variable plus derivative of y, and this one has to be also function of independent variable. So that's the linear, and when we have a linear form, then we can find integrating factor, which is mu t. Integrating factor is e raised to integral of this function, which is px. Okay, and when we multiply both sides by this integrating factor, magic happens. We'll see that in a moment. So this one is, okay, this one is, let me rewrite one more time, okay. This one r secant theta, okay, it's like px is like secant theta, so let me use correct color. So r secant theta plus derivative of r, dr over d theta, okay. I mean, this one is like y, and this one is like dy over dx, and this is like px. Okay, so this matches. I mean, this one is linear. Equals, this one is also cosine theta. Theta is independent variable, so this is a function of independent variable. This one is function of independent variable. So here, this is linear. A linear, I don't have to write, but just for reference, ODE, okay, with respect to r. R is the dependent variable. That's what we are trying to determine in this problem, solve for r. Here, if we compare with this one, linear, that means like px, but it's a theta, is secant theta. Okay, it's like px. Then we can find integrating factor, because this is linear and it helps. Integrating factor if mu x, but okay, we had mu x earlier, not t, my bad, mu x, but in this case mu theta is e raised to integral of this secant theta, okay, d theta. Now let's integrate. So e raised to, what is this? The integral of this one, okay, which one is not easy. Let me recall that. Secant theta d theta, okay, that one from calculus 2 we saw that natural log of secant theta plus tangent theta. Okay, this one is not usual, but that's the integral. Antiderivative of secant theta is natural log of absolute secant theta plus tangent theta. Now we can cancel e and natural log, their actions cancel. And look at this absolute value. We want the whole thing inside these vertical bars to be positive, and we are in the situation theta in between 0 and pi over 2, first quadrant, not including 0, sorry, because secant of 0 is undefined, but we don't have that situation. And tangent pi over 2 is also undefined, but pi over 2 is not there. But anyway, this one is positive, always positive in this range, because theta is in between 0 and pi over 2. That means we don't need absolute value. E and natural log cancel. We can simply write secant theta plus tangent theta. Now we multiply this star, this standard form of linear equation, by this integrating factor. Okay, and we know that when we multiply this by this whole thing by integrating factor, left hand side will be automatically derivative of dependent variable and integrating factor, whatever we have here. Let me put this one. And right hand side you multiply qx, that's in the question, by integrating factor mu x. Then we integrate both sides with respect to x. So we do the same thing. Then after we find the integrating factor, then this equation star becomes, we are skipping steps because we have done several problems. The left hand side will be derivative of, so here theta, derivative of dependent variable, which is r, times the integrating factor, which is here secant theta plus tangent theta, is equal to, we are multiplying both sides by the integrating factor, and left hand side will be automatically this. Okay, and right hand side is cosine theta already there. We multiply by the integrating factor secant theta plus tangent theta. Okay, so then we integrate both sides with respect to theta. Okay, we integrate. That means here this is gone, so r times secant theta plus tangent theta equals, let's distribute, then we are integrating, so let's distribute this and we can simplify cosine theta times secant theta. Okay, what is cosine theta times secant theta? Secant is reciprocal of cosine, so cosine theta times 1 over cosine. Cosine cancel, that product is 1, by the way. And what is cosine theta times tangent theta? Cosine theta times tangent theta is cosine theta times, this is sine over cosine, simply sine theta. So we are integrating, when we distribute, that's 1 plus sine theta with respect to theta. Okay, and we are done. Left hand side is just clear. Now right hand side we integrate, then isolate the dependent variable, which is r. So r times secant theta plus tangent theta equals, antiderivative of 1 is x, but the variable is theta, so theta plus antiderivative of sine is negative cosine. Okay, so we got negative cosine plus some constant of integration. Then finally we need to isolate the dependent variable, so r equals whatever that divided by this, and we don't have to simplify, there is nothing to simplify, all over secant theta plus tangent theta. Okay, plus means this is a block, so we don't have any cancellations, anything. Final.